recording.
Subscribe to my YouTube channel, PewDiePie.
Goodness gracious. Okay. I'm going to ask you on this test to tell me how far out a polynomial must go for a certain error, which is different than telling me the error of a polynomial you've created. Okay? So, in this case, we need a calculator for this. We're going to make a polynomial for sine of x squared. We're going to approximate sine of 2, and we're going to see how far out do we need to go so that the error is less than 0.0001. Sound good? Excellent. A series for sine of x squared, hopefully you all know this, is, if my pen will cooperate, the summation from 0 to infinity, negative 1 to the n. It should be x to the 2n plus 1, but it's going to be x squared to the 2n plus 1 over 2n plus 1 factorial. Is that okay? Which is really, if we combine that, which I'm going to, x to the 4n plus 2. Cool. If you drop a 0 into there, you get x squared. This is an n, not a 2. Right? 0 in there. Is that x squared? Yeah, it's x squared. Minus. If you drop something else in there, a 1, right? That makes sense. You get x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial, and we'll go one more just for fun. X to the 16th over x to the 18th over 9 factorial. Cool? Dot, dot, dot. If I want to approximate sine of 2, what am I going to plug into this thing? What? Say it with confidence. Root 2. Yeah, we got to put root 2 in there for x. Okay? So that's going to make sine of 2. So here's what I know. I know my terms are going to be root 2 squared. So basically 2 minus 2 to the 3rd over 3 factorial plus 2 to the 5th over 5 factorial. Yeah, minus 2 to the 7th over 7 factorial plus 2 to the 9th. That's not 29. 2 to the 9th over 9 factorial minus dot, dot, dot. Okay? I want to know how far out do I need to go to get error less than 0.0001, but because this is an alternating series that converges, because sine converges everywhere, all I need to know is when do the terms get that small, then I can stop. Okay? So you can do a couple things. You could keep on guessing and checking, like 2 to the 9th is that divided by 9 factorial, which is in math. Probability, right? 4. Badoom. So we're not there yet. Okay? So I can keep on guessing and checking. Or, if I'm super smart, which I am, we can, very smart, the most smart, I can enter in the pattern for this. What is going on here? So every single one of these is going to be 2 raised to a power, right? But that power is really just 2x plus 1 at this point. Boom. Divided by 2x plus 1. Again, you don't have to go through all this if you don't want to do it. I'm just showing you an alternative way to attack it. Kablow. So I'm not going to graph it. I'm going to make up a table. Okay? And let x go down and see how far out I need to go. So if I make up a table for this, we'll start it out at, it doesn't really matter, 2. And no, we got to change by 1 basically. It's okay? And I'll hit second table. And we just see when do they get that small. So here's the one we're on, right? Now that's 9th power though, which is really, keep in mind, the 18th degree of our original thing. That's the question I'm asking you. What degree do we have to go out? Okay, so that's the 18th degree, not far enough yet. Boom. If you go one more, you've got 4 O's and a 5, which is small enough. Oh, so actually, because that term is small enough as our error, we don't need to go any further. Makes sense? Remember, the error is the first unused term. Since that term is small enough, the 18th degree actually is enough. Okay? So the error associated with this, yeah. If I go out this far, I get to this term, right? So, I mean, my evaluation for this is this right here. Cool. If I stop right there, the error is the next term. Cool. And the next term, which I put in my calculator, will have to be small enough. Okay. Again, I'm not going to make it like the 100th term. So if you just keep guessing and checking, you're going to see. Okay. But that's what you're going to say. The error, which is really sine of 2 minus, we'll call this piece of 18 of 2, really, is less than the next term, which is, I forget already, what's it going to be? 2 to the 11th over 11 factorial, okay, which is less than 0.0001. So we need to go out to the answer is the 18th degree. Make sense? You're just going to take it out until the terms get small enough. It's going to be alternating. If it wasn't alternating, it'd be a whole lot harder because then you get a Lagrange error, which is kind of a pain in the butt. I don't know. Who knows? No, we'll keep Lagrange error relatively simple. Okay, if it's not alternating, I'm just going to ask you like, what is the error of this thing? Okay, and I'll keep it like the AP test does. Either I do have a graph or something like that, or like to tell you what the derivatives are, something like that. Okay. Yeah, definitely calculator test. So again, we have given a polynomial. Can you tell me what the error is? We have given an approximation we want to make. How far out do we need to go? Okay. And my next question is, given a polynomial with a known degree, how far out can I go with x? Okay, like how far can I go from the center? The further you get from the center, the more the error increases. So I'm asking you, how far can I go? We're going to do the same thing I just did for this last question. It's going to look a little different, but I'm going to use the calculator to do it. Okay, so the 6th degree polynomial for cosine is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, right? That's the 6th degree, which we want. Now, no matter what I plug into this thing, that's an alternating series, which means my error is just my next term. Okay? You see, I'm just exploiting that over and over again. Okay? So the error between cosine of x and p sub 6 of x is less than x to the 8th over 8 factorial. Okay? I just want to go out from the center 0, from 0 out until that becomes bigger than 1,000th. Cool? So, I'm going to y equals, I'm going to type that in there. Everybody with me? A little weird. Divided by 8. Math. No, not math. 9. Ah! It's not funny, Caleb. Divided by 8 math over 4. Yeah, what was I doing? 9. Okay. And again, I want it to be less than 0.001. So you can make a table, go up. But so the problem with this is a table, x values aren't going to be the whole numbers here. Okay, there's going to be a weird decimal. So what you really do then is a graph. So I'm going to graph this thing and see, it's going to start out at 0, and it's going to start to increase as x gets bigger. So I'm going to graph it and see when it gets above 0.001. So I'm also going to graph 0.001, or 0001, right? Nope, 001. All right, and I'm going to set my window. X is going to go from 0 to 2, and y has to be really small because I'm looking for a 1,000th. So I'm going to let y go from 0 to 0.002. Okay, and all you're going to see is a graph come out like this from the origin, right? And there's going to be a line coming across, and they're going to hit, and that's where we have to stop. Okay, so graph. There it goes. Took it a while to grow, but it shoots up pretty quickly once it gets away from the center. A little bit away, and there you go. So that's the x value where it stops being less than that. Okay, so I always got to find that value. So second trace, what do we intersect? 5. U guess.
So you just graph x over.
Yeah, because that's the error term, right? So I just graph my error and see when's it hit what I want. So we can go out to 1.587. Okay, and actually that means we can go down to negative 1.587 because this thing's symmetric like that. Okay. So most of the time, though, if they ask a question like that, it'll be for what x values, and they'll put like a parenthesis, x greater than 0, something like that. Okay. I didn't have that on here, so this is the answer to that question. If it said x greater than 0, then obviously we would just worry about 0. Okay. We don't have to check like the negative side of the graph we made because this is always an absolute value. It's always positive, so it doesn't matter. Sound good? Okay. The rest of these should be pretty straightforward. The arrow one's a little weird. Find a Taylor series for, this is a geometric thing, but I want it centered at 3, which means I need an x minus 3 at the end of this thing. So that's x over something plus x minus 3. What number do I need over there? I need a 4 to make it a 1 plus x, right? I don't want that 4 there. It has to be a 1, so we're going to factor out a 4. So this is really x over 4 over 1 minus negative x minus 3 over 4. You all see what I'm doing? Like I'm taking a 4 out of the bottom, which makes it this. Cool. I'm just moving that, dividing by 4 is the same thing as putting a 1/4 up top, and I'm making that plus minus a negative, basically. Okay? So the first term is x over 4, and the radius is negative x minus 3 over 4. But that's centered at 3. That's what we want. Because this was this, I need this x to become x minus 3. Well, 4 plus x minus 3 is 1 plus x, same thing. Okay? So this is the summation starting at 0, going to infinity, of x over 4 times, and so it's really negative x minus 3 over 4 all to the n. Cool? I'm going to break that apart. There's really 3 things in there. There's a negative 1 to the n, there's a 4 to the n, there's an x minus 3 to the n. That's not super important for this particular question, but if you ever have to derive or integrate a series, you want just x minus the standard to the power all by itself, because that's what you're deriving. If we had to derive this and you left that divided by 4 in the parentheses, now you got to do chain rule and stuff. Okay, we don't want to worry about that. All right, but that's that. And the interval convergence, so R is, I know I broke it apart. R really is, though, x minus 3 over 4, right? I need that to be between, or I need the absolute value of it, really, because it's geometric, just to be less than 1. So I need the absolute value of x minus 3 to be less than 4. And when you're finding interval of convergence, don't move, like you want to get to the center, the absolute value of the center. So that means from 4, we can go up 3 and down 3. So I can go up to 7, down to 1. Okay, now technically we are supposed to check those endpoints, but because it's geometric, we know it doesn't converge at its endpoints because that will make R 1, right? R has to be less than 1. So the interval of convergence here is from 1 to 7. Shut up. Yes. No, it's 4. No, it's the center is 3. Oh, I said that backwards. From 3, we go up 4, down 4. There, yeah, you're right. Good. Because it's a geometric series, and they'll never converge at their endpoints. Because if you put a 4 into there, you're going to get 1 to the end, which diverges. Look, this is really this. It looks way more complicated than it is. So it's really x over 4 times negative x minus 3 over 4 to the n, right? That's really what we're working with. If you put it, so if you said check x equals 7, when you drop a 7 into there, you get negative 1 to the n, basically, right? Summation, oh, and this is a 7, right? Well, that's negative 7/4 plus 7/4. It's just like the exponent thing, like the exponential has to take it to 0, and that doesn't if it's there. That's true of all geometric series. Okay? Not too bad? Okay. This is something that I feel like maybe I didn't explain it super well. Like, these are easy questions. All right? Just going to be careful about it. And all we're doing is power rule. That is it. So I'm going to write a series for e to the t squared. Okay? I know e to the x is x to the n over n factorial. So, and I'm using t here. A lot of y'all in the last thing used x's, okay? We use t in there because x is the variable we're integrating to, which is different. Okay? E to the t squared is the summation from 0 to infinity of t squared to the n over n factorial. Okay? If you're going to integrate it, just write out the first few terms. Like, you don't need to, but it'll help you check that you're correct. Okay? The very first term of that is 1. The very next term is t squared. The very next term is t to the 4th over 2 factorial, and we'll go one more, t to the 6th over 3 factorial. Sound good? That goes on forever, right? Dot, dot, dot. I want this thing to happen. So I'm going to integrate from 0 to x this summation. Now I know that looks scary, and you don't like it. Okay? It's an integral with a summation, and it's weird. But all that summation is this nonsense. Can you guys integrate those terms individually? Yeah, t, right? This becomes t cubed over 3. T to the 5th divided by 5. T to the 7th divided by 7, right? All we're ever doing to integrate that is adding 1 to the exponent and dividing by the new exponent. Cool? That 1 over n factorial doesn't matter. And this is different now, so let's be careful. We have the n plus 1 term where we add 1 to n, which would make that exponent 2n plus 2, right? We're not doing that here. We're just adding 1 to the whole exponent. So this becomes the summation to infinity t to the 2n plus 1 over 2n plus 1 times n factorial. Is that okay? I added 1 to the exponent and I divided by the exponent. That is the power rule. Okay? The n's are just numbers. And you can check this because if you integrate those terms, you should get t plus t cubed over 3. And we'll do one more, plus t to the 5th over 5 times 2 factorial, right? Now, what happens sometimes, not all the time, and not in this case, is sometimes you lose a term or gain a term. So something weird happens here. But you should check and make sure n still starts at 0. The way you can tell is I need my first term to be t to the 1st power, right? I got that because I integrated the first term up here. Well, t to the 1st power is going to happen if I start at n equals 0. Cool? Now remember, this isn't our final answer. It ends up being the same thing, but only because of how it's set up. We're really integrating that from 0 to x, right? So I have this from 0 to x, which means I have dot, 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 this from 0 to x. You don't need the right-hand side over there. I'm just writing that out to check that my series is correct, because it's easier for me to integrate those terms than it is a series. It looks weird. Okay? But you can verify that that works. Plug in 0, plug in 1, plug in 2, you're going to get that series. Okay? Now I plug in x for t, so we get the summation n equals 0 to infinity, x to the 2n plus 1, right? Minus, everybody good? Plug in 0. But it turns out, this is not always the case, but if you plug 0 into that, you just get 0. Is that okay? Because you're plugging in 0 to this crap. But if we were plugging in 1 or something, we'd have this whole infinite series here we'd have to figure out. They usually do not do that to you. So this is just minus 0, so the series is just that thing. Cool? I took a long time to go over that, I think, but all I did was the power rule on the e to the t squared series.
Wait, so when it asks for this degree polynomial,
Yeah.
you don't really care about what the series is.
Oh, crap, you're right. I'm finding a series for that thing. You're absolutely correct.
Okay.
I could have written out the first 3 terms of this and integrated those.
That's what I was going to ask.
Yes, I'm answering a totally different question. Well, a similar question, but different. Yes, we don't need that at all. Our answer is, man, thank you. Our answer is, if they ask us to find the series, there's a series. But our answer is x plus x cubed over 3 plus x to the 5th over 10. Cool. All right. So, yeah, that's why I always attach those anyway when I'm working with the series, because you can still see what's going on a little bit. Helps you out. Okay? And then the last thing we got is a free response question, which I'm not going to tell you which one it is. These answers are online. I'm just going to run through this real quick, just for fun. Okay? Notice they're giving us a function which is a variation of a series we know. We know the series for e to the x, so we know the series for that function. All right? Very first thing they ask us to do is find the first 4 non-zero terms and the general term for that thing. So I'm going to change e to the x into that thing. So I'm going to write 8 out here. That is the summation n equals 0 to infinity. That 6 is just there. It does not matter at all. Okay? The series for e to the x is x raised to whatever power, right? So we really have negative x over 3 to the n over n factorial. Everybody handle that? What are you doing? Are you taking pictures? Okay, that's our general term. We can simplify that if we want. That's the same thing as the summation. You don't have to do this on the AP test, but if we're going to work with it, you might as well. Negative 1 to the n. What? Oh, you got a good picture of Caleb? Good. Don't listen to her, Caleb. You be you. Okay, a little weird. Okay, and the first 4 non-zero terms of that thing, which is what they want, right, are plug in 0. What are you going to plug in 0? You get 6. Okay, when you plug in a 1, you get negative 2. Dividing by 3 to the n and then dividing by 7 out just puts them both on the bottom. Yeah, like 1/2 divided by 3 is a 1/6. Okay. Okay. Just to make sure, that's not the same thing as 1 divided by 2/3, kids. That's 3/2. Okay. It matters which one's the big fraction bar there. Sometimes you guys probably don't come across this much, but sometimes I'll see questions like this. I'm like, that's a terrible question because I don't know which one's like the real fraction bar. You know what I mean? Use the same sign. That's bad. That's bad to do. Okay, is that right? If you plug 1 in there, you get 6, negative 1, 1, 3. 6 over 3 is 2. Yeah. If you plug in 2, you get 6x squared over 18, which is x squared over 3. If you plug in a 3, you get 6x cubed over, what's 3 factorial? 6. So that cancels out over 27. How's that? You can take your time and go a little slower, but that's how that works out. That. The general term and the first 4 non-zero terms. There they are. Okay? That's A. B says, yeah, find the first 4 non-zero terms of this thing and the general term. Again, you see as it's going 0 to x, you're going to integrate it with a t in it, plug in x, and then plug in a 0. The 0 thing's going to go away. So, B, all we are doing, because it wants the general term, I'm going to just integrate this. The 6 doesn't get integrated. The negative 1 to the n doesn't get integrated. X to a power gets integrated. N factorial times n plus 1 is n plus 1 factorial. Right? Yeah, that's that. But that is the same exact thing as 6x. We're going to start at 0 because that matches up with that term. Minus x squared plus x cubed minus, is that right? Did I do this wrong? No, not x cubed. X cubed over 9. And x to the 4th over 4 times 27. 108.
So if a question didn't ask for the general term and just asked for the first 4, you could just take the first 4 from the other, you can integrate.
Mm-hmm. And when you do the general term, just make sure it works out with those terms. Like you plug in 0, you get 6x. Plug in 1, you get x squared. Okay? Just make sure it works. Factorial has nothing to do with power rule. This x to the n becomes x to the n plus 1. Yeah? When you integrate, you divide by the new exponent. So technically down here is an n plus 1 I'm dividing by and an n factorial. Right? Because that's what was down here to begin with. And a 3 to the n is still there too. I'm just saying n plus 1 times n factorial is n plus 1 factorial. Make sense? You don't have to write like that. I just being lazy. Cool? All right. So we got all that junk. That's that. What's C say? The function h, which is k times f prime of ax. Whew, this is a tough question. So here, let me steal this. What just happened there? I'm trying to grab. Oh, it's a lasso. Whatever. Okay. Is the Taylor series for this thing. Find the values of a and k. Yeah, when they do this to you, most of the time, they're going to give you a series that you should. What series is that? It's e to the x, okay? That's e to the x. So they want kf prime of ax to be e to the x. We can do it through the series, or we can do it through just the function. All right, f of x is that thing there, 6e to negative x over 3. So f prime of x is, it's e to the negative x over 3 again, right? But then you multiply it by negative third, so it becomes this. There was a 6 out there. Now it's negative 2. Okay with that? But we don't want that to be that. We need, again, k out front and an a in there with that x. So if that's f prime of x, kf prime of x, ax, is really negative 2k e to the negative ax over 3. But what do we need that to equal? It has to equal the series we're asking about, which happens to be e to the x. Well, if that has to be equal to e to the x, what's k got to be? Negative a half, definitely, and a has to be. That's it. But you got to recognize that that's what that is, right? And set up the derivative. So I did that completely without the series. I'm going to do it with the series to show you what it looks like in case you had to.
So you just straight up derive one term for, okay. And then that times k. How'd you get the negative 2k?
Because it said in the question, we need h of x to equal k f prime ax.
Okay. So it's like one of those, it's like IC.
Yeah, so I multiplied it by k, yeah, and then put an a in with the x, that's all. So let's say we went with the series, though. So we don't have a series for f prime, all right? But we can find a series for f prime by taking our series for f, which is right here, and deriving it. So our series for f prime, so again, if we work with a series, our series for f prime, this is kind of annoying, is, where are we at here? 0, right? Negative 2, plus 2/3 x. So let's write this out. 0, negative 2, plus 2/3 x, and I'll go one more out. Plus, what, x squared over 3? Minus x squared over 3. Does that make sense? That's f prime. We need the series k f prime ax. Well, all that does is multiply all these by a k. So this is negative 2k. Huh? No, the 3 cancel with the 9, right? Oh, I looked at b. Oh, I did the wrong thing here. I derived this stupid thing. It's negative 2, 2/3 x, x squared over 9. Oh, you're right. Okay, cool. I derived the integral. Is that right? Okay. So we put a k in there, multiply all the terms by k, and put an a in with the x. This becomes 2k over 3 ax. And this becomes a squared x squared k over 9. Now that seems complicated, but all that is a whole bunch of terms that tell me what I need to do. Remember, we need this to equal 1 plus x squared over 2, right? That just gives me all these equations. Look, right away. What's k have to be? It has to be negative a half, right? It has to spit out a 1 there. So, and once I know k is negative a half, this becomes negative 1/3 ax. But that has to equal x. Well, the only way that's going to happen is if a is negative 3. So there's 2 ways you can attack that. All right. Great job.